alcohol access influence alcohol acceptance in adolescent rats?
I'm Olivia Bagg.
I'm Katie Stewart. I'm Bella Wallace. I'm Ansely-Brooke.
I'm Jasmine.
I'm Chanson, Bullard.
Alcohol use disorder is a disorder that is characterized by the persistent drinking despite risk factors or the aversive taste of alcohol. There are two main risk factors for the development of AUDs, and that is age and taste perception. Studies have found that young individuals tend to adopt more patterns of binge-like drinking, which is the consumption of 4 to 5 drinks at least once every 2 weeks. And there also have been links to sweet liking and actually having a paternal family history for alcoholism. And those that have a bitter sensitivity tend to initiate drinking more often than those that do not. And rats, as some of us know, have a very similar neurophysiology to humans. And so researchers have actually created models, both long-term and short-term access models with rats, so that way we can more clearly and directly look and examine how those factors can impact the development of AUDs later in life.
So many of these rat models look at the taste components of ethanol. Ethanol does not fall under any of the 5 basic tastants, which are sweet, sour, salty, bitter, and umami. However, many of these models have shown that when rats are exposed to ethanol, they exhibit similar licking behaviors to when they're exposed to sucrose, which is a sweet solution, and quinine, which is a bitter solution. In fact, when both of these solutions are mixed together to form a bitter-sweet solution, rats exhibit the same licking behavior. So why is this important and relevant? 1 in 10 individuals in the United States will be diagnosed with an alcohol use disorder. Thus, understanding the underlying mechanisms that lead to these disorders is equally important. So why is understanding the taste components of ethanol important? This is due to taste having the ability to drive certain behaviors. If an individual finds the taste of ethanol more pleasant and more enjoyable, they're more likely to consume it at a higher rate and higher concentration compared to an individual who finds the taste aversive.
For our study, we used 30 Sprague daily adolescent male rats who were all naive to the taste of ethanol. We had 4 conditions. The first condition was the brief access to ethanol exposure. These rats were exposed to 30-minute testing periods 3 times a week in a gustometer. They were given 6 concentrations of ethanol and 1 sample of deionized water. They then had the chronic intermittent access group, which is the CIA group. They were given a 2-bottle preference task in which they had 1 bottle exposed with 5% concentration of ethanol and the other bottle was deionized water. They also had this for 3 times a week for 24 hours at a time. After a 24-hour testing period, the bottles were taken off the home cage and weighed to measure the volume of liquid that they had consumed in that time.
So the third group we looked at was the continuous or constant exposure to ethanol group. This model involves exposing rats to ethanol for a period of upwards of 24 hours over the course of several days. For our experiment, our rats received 2 bottles on their home cage, 1 filled with water and the other with a 5% ethanol mixture. These bottles were weighed and removed every 12 hours to measure consumption and therefore preference. This was done for a total of 12 days. Following those 12 days, these rats were put into the gustometer and measured with sucrose, quinine, and ethanol. The last group we looked at was the forced access to ethanol group, which we called the Bagg group. Unlike the previous 3 groups, this model only was exposed to ethanol for a total of 6 days. During the 6 days, they were weighed every day to ensure that they remained healthy, and then their bottles were weighed every day to measure consumption. Unlike the previous 3 groups, this group only had 1 bottle containing 5% ethanol. After their 6 days, they also underwent those post-tests. It's important to note that unlike the previous 3 groups, this group was formed using the K model, meaning that these rats had already been pre-exposed to ethanol. If we were to redo this study, we would use alcohol-naive rats like we did the previous 3 groups.
So EC50 is a measurement that we use and we'll refer to a lot in the results section. So it's the half maximal effective concentration, and that's defined as the concentration of a substance when it produces 50% of its maximum effect. But for our research, it's when the rat's licking response was halfway between the baseline and the maximum lick rates. So we have an example graph here, and at 1 that would be defined as the maximum lick rates, and then down at 0 would be 0 licking. So when the lick ratio is at 50%, that's our concentration that would equal our EC50 value that we used.
This is the formal formula for it, and that's the calculator we used online.
So this is the Davis Registometer. It's an apparatus we used to administer taste stints in a controlled way, in a controlled time manner. Basically, there's this small lever arm that you can see in the video that allows access or prevents access to the taste stint bottle that's being presented at the moment. And we used this in the pre and post test for all groups and for the Bagg group during their alcohol training. The tastings were presented at 45-second intervals, and it was repeated twice if they did not initiate licking behavior. If licking behavior was initiated, licks were taken over a 15-second interval before moving on to the next tasting. So based on prior literature and experiments, we formulated 2 research questions and 2 subsequent hypotheses. Our first research question was, how do the Bagg, CIA, and K treatments affect acceptance of ethanol, sucrose, and quinine? And we hypothesized that acceptance of ethanol, quinine, and sucrose will increase from pre-test to post-test. And our second question was, what changes will be observed in the EC50? And we hypothesized that the Bagg group will experience an increase in EC50 or licking patterns.
So these are our results for the ethanol portion of the analysis. So anywhere where there's a black line is pre-test values and gold lines represent post-test values. And then anywhere where there's an asterisk is a statistically significant difference between their pre and their post-test. So the only group that had no difference between their tests was the CIA group. And then if you look at the Bagg group, they had their 3 marked concentrations were significantly higher in the post-test than they were in the pre-test. And that same is true for the FA and the K group. But we thought it was interesting that in the K group, they actually showed a higher lick ratio for the highest concentration, which was 40% ethanol. And then as Jasmine said, the K rats were used again for the FA model. And so we just wanted to point out that the gold post-test line for the K group was the pre-test values for our FA group. And then looking over here, this is our ethanol EC50 values. So an EC50 was calculated for each rat in each condition for pre and post testing, and this is the ethanol one. So again, the CIA rats had no significant difference between pre and post test, but then all 3 of the other groups did show a significantly higher EC50 average on average.
So for the sucrose testing, as concentration increased, so did the amount of licks, which was as expected. And we see that especially for the Bagg group, when the concentration was at 250, we saw a significant increase in licking. And if we look at our EC50 scores, the Bagg group had a significant increase from pre-test to post-test.
So here we have the quinine results of our study, and as you can see, as concentration increases, lick ratio decreases, which is the expected pattern, especially for an aversive solution like quinine. So once again, the CIA did not show any significant results from pre-test to post-test. However, the Bagg and the K group did show a slight increase in lick ratios at 0.1 millimolars of quinine, and this shows that there was a slight reduction in bitterness aversion, especially at the middle range concentration levels. But the FA group actually had the biggest increase in lick ratios at 0.03 millimolars of quinine, and this shows that quinine became less aversive after the forced access exposure. And then here you can see that for Bagg, K, and FA, average EC50 values increased after exposure, which showed that these 3 exposure groups became less sensitive to bitterness overall. So in conclusion, the CIA group was the only group that showed no significant changes at all. So there was no increase in acceptance for any of the 3 tastings, there was no EC50 changes, and no lick ratios. And this is likely due to how spaced out the exposure periods were. So like Olivia mentioned earlier, the CIA rats received 5% ethanol every 3 times a week with 24 hours in between sessions. So by the next session, the rewarding effects of the ethanol had already worn off. So due to that, there wasn't enough reinforcement in the brain to associate the taste of the ethanol with its rewarding effects. And this pattern is actually seen in humans, so people who drink infrequently at lower levels don't tend to show a preference or tolerance for alcohol or any changes in that. But people who binge drink or consume alcohol more frequently actually have alcohol in their system more consistently. So this strengthens the reward pathways in the brain, which can actually increase motivation to keep drinking over time.
Okay, so for our Bagg group, we saw a significant difference across all 3 taste and stimuli. But then for our K and the FA group, we saw an increase in total rate of consumption within the ethanol and the quinine, but not for the sucrose. All three groups showed that there was an upward shift in lick ratio patterns, and as our results saw previously mentioned, that there was an increase in EC50 concentration between pre-test and post-test. So these pre-test and post-test comparisons revealed that there was an increase in preferability for ethanol, which is revealed in the increase in total rate of consumption of ethanol. This indicates that there was stronger motivation to consume more, and there was also a shift, a noticeable shift in the palatability towards the bitter stimuli of quinine. These, the consequences of these shifts can be contributed to the fact that the binge drinking, constant access, and the forced access exposure models all kind of did not have the breaks in between like the CIA did. Therefore, as Bella previously mentioned, the fact that they were having the reinforcing effects of ethanol every day, or with the Bagg group at the higher concentrations, those reinforcing effects led to more vulnerability and higher motivation to consume more. So in other words, if we relate this to the human aspect, if we consume constant or repeated exposures to ethanol, then the vulnerability to form an addiction to alcohol increases. Thank you so much for taking
So you spent the semester with the rats, right?
Mhm.
So beyond like flavor preference and consumption, did you notice any other shifts in their behavior?
We were focused on the taste acceptance, which is why we use the EC50, and especially with like the chronic intermittent access, the duration between exposure periods, the rewarding effects wore off. But for the binge access and continuous access, we used 5% ethanol for all of them, so we didn't really notice any behavioral changes, but we more so focused on the taste and acceptance of ethanol.
So you said you didn't see a significant change in the CIA group. If you were to run this experiment again, like what steps would you take to get a more significant result out of this group?
Yeah, I think we would do it for a longer period of time. So obviously, since it's a senior thesis, we have a limited amount of time to do the experiment, but we did it 12 sessions over 4 weeks, 3 times a week. So I think maybe if we did this for a little bit longer into the next semester, we might see more significant results. So I think if we did it longer, we might see if timing is a factor in that.
So like concentration, is that what you were going to
Yeah.
say? Yeah. We used 5%, which is a little bit less than what has been done in previous literature. Previous literature have done 10 to 20%. And we really wanted, that's why we did 5%. We wanted to do something a little bit differently. And that could have just been too low for them to have that response. So also, in addition to making a longer study, maybe looking at different variations of concentrations could also help us improve.
Where does the uncertainty in your measurements come in from your graphs? You have the uncertainty bars. Is that like solution prep or time of experiment?
Are you talking about the standard error bars?
Yes.
Yeah. Was that just the deviation, like the individual rats, I believe?
These are all male rats, correct?
Yes.
Do you think there would be a difference in female rats?
So in prior literature, I believe, at least in one study we read, that female rats had more of an aversion to the bitter tasting, and we avoided using female rats in our experiment, as a lot of people do, just because they believe like the estrus cycle and the hormone fluctuations can cause compounds and results.
Now, I don't have alcohol use disorder, not that I would admit that here, but I think I may have a caffeine addiction. So I guess like thinking about the concentrations of sweetness flavors or bitter flavors, like did y'all see anything in the literature like strategies to maybe prevent certain behaviors from happening if you have experience to these tastings? Like what would you suggest to me to maybe counter my caffeine addiction?
I think our study focused more on the different animal models, and so that's why we were exploring the different kind of ways that you would develop more of the addiction rather than trying to prevent it.
Yeah, I think like if we were, like with our study with ethanol, like Jasmine said earlier, ethanol has like bitter and sweet components. So we tried to see like if you reduce the aversion, if that would so people have obviously there's other factors like genetics and family history. So maybe like in adolescents and humans, if you have reduction or don't have an aversion to bitterness, and you like sweet stuff more, that might cause you to have alcohol use disorder later on. So I think that's what our study kind of seems to aim at, and maybe this could be implemented in strategies like that.
Yeah, and going on back into like some of the previous study has found like that those that had a sensitivity to bitterness were more likely to initiate that first consumption of alcohol. There could also be something with an individual's taste perception being a risk factor to maybe taking on more of those habits of drinking. So I would look at, if you're looking for yourself, you have and look at your family history and look at your own taste perception and see before deciding if you want to consume caffeine, I guess.
How would you specifically relate this data to, say, helping college kids who are new to an environment with alcohol?
I would say that what our study found was a clear, across all conditions, the Bagg group had a big effect on the acceptance of alcohol. So I would say understanding binge drinking, what it is, and how to maybe prevent it in yourself, because we see that for the CIA, having that break is very important to stop that reinforcement that leads to addiction. So I would recommend just understanding what binge drinking is and how to identify it.
I'm going to apologize because mine and Dr. Pittman's research overlap somewhat, so I'm going to ask a few technical questions and some statistic questions, but it's because I'm really interested, so I'm sorry. The why just males was answered, but were these curves all generated when the animals were under water restriction?
Yes, they all had 24-hour water restriction before each.
Did it affect the number of trials that they took, or was that standardized throughout? Or did you see any change in the number of trials they initiated?
They kind of vary between the rats. All
Sure.
of them were very individual. There were some cases where when we were testing for sucrose, we would take off their water a lot later. And so sometimes they wouldn't initiate drinking or like on the post-test as quickly as say they would have if they had the 24-hour access. So that was kind of the only thing we really observed, more of the post-test and pre-test, not in between in the trials.
I meant the trials in the
trials?
in the gasometers.
Yeah, we created a like 30-minute time
Sure.
requirement for it, and we had a set number of trials, but some rats completed that, and that was like their trial of the Davis rig. Or yeah, they had a cutoff, and if they didn't want to drink that day, they would do as many as a 30-minute time.
Okay, so you had a maximum. Exactly. I gotcha. Okay. For your curves, what do the asterisks show?
Significance.
Sure, but like
From the post hoc.
Is that from a post hoc?
Yes, that's post hoc significant results from the individual concentration.
Okay, so like there was a group by concentration interaction and then follow-up post hoc test showed that was, okay, gotcha. And then the last question, I promise. Sorry, you get excited about this. Did you analyze or did you notice any correlation between, like, talking about the variability and such, your big drinkers and their performance in the Davis rigs? Did you run any analysis of that, or did you happen to notice anything?
We did not conduct any analysis on that.
All right. Okay.